Hi, today we're going to do a demonstration. Essentially, one thing that we're bringing to the forefront here is that WebAssembly requires its own language SDKs and compiler toolchains, and this makes it quite a constraint developer environment. In saying that though, compared with Docker, WebAssembly has the potential to be, say, up to 100 times faster at startup, and also has a much smaller memory and disk footprint as well. So one of the great advantages of Docker is its rich ecosystem of tools. So it seems that there's advantages on both sides. For example, speed, performance, and safety of WebAssembly's niche developer environment and tool chains. And we compare this with the flexibility and the low barrier of entry of this containerized environment, i.e. Docker and so forth. So what if we could achieve the best of both worlds? Well, at WasmEdge, we'd like to bring together this Docker-like tooling to developers in the WebAssembly space. So essentially, we're talking about the future of OCI, so Open Container Initiative, compatible runtimes. Specifically, what we're going to do here in this demo today is we're bringing WebAssembly, i.e. the WasmEdge runtime, into the Kubernetes ecosystem. So we have an article here, which is a demonstration with code, and we're going to do that today. So if you wanted to pause this video, or depending on where you're watching this, you can have a look in the description for a clickable URL. So the first thing we do is we install some packages here. So it says here that, first make sure you have these dependencies and packages. So this block of code here is going to resolve all of that for us. But I've just opened up these clickable links here in new tabs. So feel free to go have a look at these. This one, for example, this Kubernetes container runtime interface is a lightweight alternative to using Docker as the runtime for Kubernetes. So back to this page here, let's go ahead and start installing these packages. Now, what I'm going to do, there's a little note here about that you may need sudo in order to get all these resolved. So what I'm going to do is make a suggestion is that you actually start an interactive shell with your super user in a different tab from where you're going to do the work. And the reason being is some of these commands, like this one down here, we're actually writing to an area on the file system that's going to need the super user privilege. So we want to make these variables available to that super user's environment. So okay, so in the interactive environment, let's go ahead and export these. And I'm going to do this live, so if you just essentially follow along, you'll understand which ones we run in which terminal. Okay, so let's just set those environment variables. Let's just actually go ahead and do a general update on this system. Okay, and then when that's done, let's go and install some of these. So sudo apt install that one. Okay, great. Okay. Now with this command here, this is the one where we're actually going to be accessing a part of the file system that's under the super user. So we're doing that in the interactive sudo shell. And then similarly, this next one here underneath it. Okay. Okay, so now we're going to add these keys. So again, we do that in the super user's interactive shell. Perfect. Okay, do another tab here. Okay, and sudo install that. Obviously, you can put a little lowercase y in there after install if you want that to just automatically install. For the time being, I just clicked Y and proceed. Okay, so that's good. Now we'll install these guys here. So we've reference these packages and tools and things. So this, as I mentioned, this code block is going to go ahead and get us everything that we need. So sudo get install those packages. Okay. And then after this, we're going to start using this command here, which will require sudo as well. So I'll do that in just a second when this finishes. Okay, so sudo. All right, fantastic. Okay, so the next step we need to do is install the WasmEdge runtime. So we're going to do that in two separate commands. First of all, we wget that install.sh. And then the second thing we do here is we want to install that, and we're going to use sudo for that. Okay, now the next section here is similar. First of all, we get that Debian file, you can see here. And then on the next line, we have to use sudo to actually go ahead and action that. All right, fantastic. All right, so now what it wants us to do is create two configuration files. So the first one we're going to create in this location. So we'll need sudo access for that. And inside this file, we just want to populate it with these two lines of config here. Okay. Then the second one is this guy here. So again, sudo by that. Now you can see here, there's already some content in here. And as this documentation correctly states, the above is the original content. So we ignore that part. What we want to do is grab this new content, and we want to put it at the bottom of that file. Paste that in there. Right, and click that. Okay, and now to restart this process. Fantastic. Okay, so for the next section, you can, of course, build a WebAssembly application from Rust. And what we've done is we've created one earlier. We've prepared one for you earlier. So we're going to just acknowledge this part here. We're going to skip past it, and also going to skip past this next section, which is how to actually build that source code and then publish a DockerHub image for that particular WebAssembly app. And so this is the documentation to do that. But what we're going to actually do is, like I say, skip over that, and we're going to go to the part where it says you can actually use the Docker tools to pull that WebAssembly app, that pre-made one that we've gone ahead and prepared earlier. So here we're going to type this command, which is pulling this pre-made DockerHub image for us. So from there, we need a couple of JSON files. So there's two of these. We're just going to create them in this same directory where we are. And the first one here is called container_wasm.json. So we go by container_wasm.json, and in that we take this JSON object here, this code block, and we pop it in there. Okay, and then the next one is sandbox_config.json. By sandbox_config.json, and then we again take the code block underneath, which is this. Okay. All right. So the next step here is to create the pod. So what we're going to do is we're referencing that sandbox_config.json file. We're running a command, which is going to access that file. As you can see here, we're getting back an identifier, like a key. So we want to make sure that we hang on to that. Okay, and we use that. You can see here that key, obviously yours will be different, but we're going to use that and actually set a system variable with the value of that key. So let's go ahead and do that next. So in our case, looking at this value down here, the command we'd use is export pod_id, and then this number starting with 712. Okay. So from then, what we want to do is run another command, and this is going to reference both the files that we created, so the two JSON files, and in addition to that, it's going to include the system variable of the pod ID. So let's go ahead and run this command. Okay, now that returns us yet another value. So we want to hang on to that. We want to save that because that's going to come in very handy later on. As you can see down here, when we start the container, we're actually putting in the return value from that create command there. So hang on to that for future use. All right, so in the meantime, let's have a look here. We'll list the container that's being created, and sure enough, it has. So that we've got the container, and that's our image identification. That's what we've just gone and fetched, and the state is created. So that all is correct. So starting the container here is we do this command here. And as I said before, what we do is we take this value from above and we actually use that as part of this command. Okay. All right, now that gives us back the correct key there. Now, if we run this same command that we did at the top, we can have another look at the state of that container. And we'll see at the moment, actually, it says that it's exited. The reason for that is that it's actually finished. So if, as this message up here says, if you see running, it'll just be because it's still running. But because this example is very tiny, the state should be exited. So if it ever says running, just wait a little bit for the container to finish and then run that command again. And then you will see that that state would be exited. Okay, so now we're going to check the container's logs. And as you can see, this uses the same key from which we used to run this. Okay, so we'll try that, and then we paste in that number. Okay, fantastic. So what we have here is the output of the WebAssembly executable. So it's random number is there, random bytes printed from WASI. This is from the main function. Okay, so this is all the output from the source code for the WebAssembly executable. And the way to check that this is all correct, so see all these outputs here that we're getting from reading the logs of this containerized environment. If we go up to the Rust source code, which is up here a bit higher, and obviously we didn't do this, this was one that we've prepared earlier, but this is the actual source code. If you go ahead and do this section, you'll see here some references, for example, like the args are as follows. So you'll see here the args are as follows, things like the file path, reading the file path, environment variables, and so forth. These have all been printed out as per this original source code, which was written to Rust and then compiled to WebAssembly and executed in this environment. Okay, so that's the end of this demonstration. If you scroll right down to the bottom of this article, you'll see some links off to various things, and feel free to join us on Slack channels, send emails, also contribute to the WasmEdge program. Okay, thank you very much for watching, and we'll see you again next time.